To accelerate biological discovery, you need smarter tools. Tools that combine the precision of genome editing with the power of hybrid learning, digital twins, and sensors. This is the core of biointelligence. I am Marco Integhini, and this is Biointelligent, a podcast that decodes biotech scientific innovation within the Horizon Europe project BIOS and more. All right, so today I'm joined by Pinzon and Yannick Baumgarten from Fraunhofer. In BIOS, Fraunhofer leads work package 8. For this specific discussion we are having today, but in general, it's involved in many more work packages within the BIOS project. And this work package 8, it's about life cycle engineering, helping assess the environmental implication of new products and bioproduction routes, and connects sustainability analysis to a broader biointelligent vision of the project. As I said, in this conversation, we will focus on Fraunhofer's role in BIOS, in the life cycle engineering matters, and on the lycopene, the so-called red gold, as a case study. Yeah, Anna and Yannick, thank you very much for joining me.
For the invitation.
Thank you for the invitation. Yeah.
And well, thank you again. And to start with, could you briefly introduce yourself and explain a little bit better than how we did it so far, Fraunhofer's role in BIOS?
Mhm.
Anna, you can start. All right.
Okay. My name is Anna Pinzon, and I'm a research associate at Fraunhofer IPA in Stuttgart, Germany, where I work with the Sustainability Modeling and Analytics group. My work focuses on developing data-driven approaches to sustainability challenges with expertise in life cycle assessment, for example, and bioeconomics, also carbon footprint and climate strategy. My role in BIOS is mainly connected to work package 8, which focuses on life cycle engineering. In practical terms, this means that we look at the environmental and economic implications of the production routes developed in the project, with lycopene, as you said, as use case. We built a sustainability baseline for conventional production methods and then compare this with the emerging biological production route.
All right, thank you. What about you, Yannick? Would you like also to introduce yourself briefly?
Sure. So my name is Yannick Baumgarten. I'm working for Fraunhofer IPA already for around 6 years now. Business segment manager for the topic of biointelligence. We will probably touch that topic a bit later on. Just a brief explanation. It's the convergence, so the intersection of biology, engineering, and computer science. I am also the secretary of a technology platform, which is European, at the Manufuture sub-platform Biointelligent Manufacturing. I am organizing a lot of different events, talking in different projects, disseminating the topic and bringing really forward this intersectoral endeavor where new innovations occur at the moment.
All right, that's good because so far in our previous interview, we didn't have this angle from participant members of BIOS. So with your background, we can kind of say that Fraunhofer is really helping BIOS evaluate not just whether something can be produced, but whether it can be produced in a way that makes sense environmentally and strategically. So that's what your also background tell us about. Just to keep going on this direction, I wanted to ask you, where does Work Package 8 fit within BIOS, and why is life cycle engineering in particular so important to the project?
Okay, maybe I can answer this. Work Package 8 is the sustainability and one of the decision support layer of BIOS. BIOS is developing biointelligent and biological production approaches, but one important message is that bio-based doesn't mean automatically sustainable. And that is why life cycle engineering is important. It allows us to evaluate the full production system. Without this perspective, the biology might be optimized, overlooking environmental burdens elsewhere in the process. In Work Package 8, we first develop a baseline for conventional lycopene extraction, and then we assess the biological route based on primary data, on laboratory data from the University of Stuttgart. They are producing lycopene using a bacteria, Pseudomonas putida, and this laboratory data we scaled up to industrial relevant scenarios with support from industry experts, also partners from the consortium. And now we are finalizing the comparison between these two routes, so the conventional and the bio-based. Then Work Package 8 has a key role because it connects laboratory development with real industrial decision making. And so its goal is not to prove that biological route is automatically better, but to identify the conditions under which it can become better, environmentally and economically, all in an industrial scale, so not laboratory, in a big scale. And that is where life cycle engineering becomes valuable for BIOS, because it turns sustainability from a final evaluation into a design criterion.
Amazing, nice. It would be fair to say that without this layer, the project could not optimize the biology without fully understanding the broader consequences in a way. One of the most visible Fraunhofer contribution has been the lycopene case study, as we mentioned already. And I wanted to ask you, why did lycopene became such a useful use case for BIOS?
Okay, that's a good question. Lycopene became a case study because Work Package 8 entails the assessment of one of the products targeted by the bioproduction approaches envisioned in the BIOS project. There are many products. Other ones were tailored proteins, metacrylates, and terpenes. So we choose terpenes because a small-scale lycopene production was set up in the University of Stuttgart, as I already told you. And there is a local connection also to Fraunhofer IPA, so it was easier to get the data. And it has become such a useful case study because first, it is a very concrete product with applications in food, cosmetics. It is this red colorant and potentially other high-value markets. Second, conventional lycopene production is traditionally associated, at least in the literature, with tomatoes and tomatoes byproducts. And finally, lycopene is a good example of the trade-offs we want to understand in BIOS. So according to the literature review, the conventional route can use a waste or side stream from the tomatoes, which is attractive from a circular economy perspective, but it depends on agricultural chains. And the microbial route, on the other hand, could decouple this production from the agricultural variability, but it faces other challenges, such as the carbon source, for example, for the microorganism, for the Pseudomonas putida. So lycopene is useful because it is technically specific, but it also illustrates this much broader question. So how do we decide whether a bio-based route is truly better than an existing one?
All right, so the lycopene is useful because it's scientifically relevant, industrially interesting, and also a good example for asking sustainability question in a concrete way. So that's the idea I had after what you said.
Yeah, and more important is that because Stuttgart the University of Stuttgart is developing these laboratory experiments, then we can get primary data from it. Because if you are going to look this data in the literature, it is not that easy to find.
Okay, so you face some difficulties in finding them in literature, so that's why it's very useful to have like someone who provides you with data right away.
Yeah, that was the idea. So because within BIOS, they are developing this new production route. So if they are developing the new production route and we have the access to the data, why not evaluating them as they are designing the new route? Yeah.
And according to what you analyzed so far, when comparing conventional production with the microbial fermentation, what are the main sustainability trade-offs you are seeing? For example, differences in feedstock, solvents, energy use, scale. I don't know. You tell me.
Okay. Yeah, it is important to highlight that each route has different sustainability logic and challenges. For the conventional route, the advantage is that tomato byproducts can be used as a raw material. So it can reduce competition with food production, for example, and can valorize a side stream that otherwise has low value. However, this advantage depends strongly on how the tomato byproducts is defined, what alternative use it would have, and its location relative to the production site. So if it is already used for animal feed or for biogas, composting, or another valorization route, then we need to account for that opportunity cost. It should not be treated as a free input. For the microbial route, the advantage is that the production can take place in controlled environments and is less dependent on this tomato cultivation, seasonality, agricultural land. It can also potentially avoid food competition. However, the biological route had its own challenges. So, for example, the carbon sources, such as glucose and energy demand for the bioreactors. So the comparison is not simply weight-based extraction versus fermentation. It is a question of it is a complete system with its own conditions and characteristics.
It's interesting because sometimes one might think that biological bioproduction is automatically more sustainable, and that's not always the case. So as you said, there are really a lot of different variables we have to take into account. And for example, what did the key hotspots in your recent lycopene assessment reveal about the real bottleneck about sustainable bioproduction?
Yeah, the hotspot analysis was very useful because it showed us that the bottlenecks are not always where one might expect them to be. For conventional lycopene extraction, we have different hotspots depending on the scale. The laboratory scale showed electricity as a major hotspot. But on the other hand, at the industrial or pilot scale, the extraction inputs become much more important. So especially the solvents where the hotspot, ethanol, acetone, ethyl acetate, and hexane. They can drive important impacts in categories such as climate change or freshwater ecotoxicity. For the microbial route, the hotspots shift a bit, at least in the industrial scale. At the laboratory scale, we also have the electricity as a hotspot because in the conventional production, in the laboratory, some of the equipment is not necessarily used at full capacity. It means you have a centrifuge or something like that, and you turn it on, but you put just a sample. So it is for, 10 samples, and you put one sample, but you use the whole equipment. But in the scale-up models, so for the conventional production, the hotspot was the solvents. In the new production route, we also have solvents for the extraction, but here the carbon source becomes very important. In our Pseudomonas putida model, glucose is a key hotspot. Glucose is the carbon source for the microorganism. So from the economic side, the current biological route is promising scientifically, but not yet automatically economically feasible. At realistic market prices, major process improvement will be still required. For example, higher titers, better biomass production, and also potentially some product export from the cells to the outside to the media, because the product is getting stuck in the cells, in the membrane.
All right. Thank you for well, this clarifying overview. Now, I wanted to ask you a follow-up question. To maybe we can involve Yannik as well in this question. Do you see somehow a trend change? So do you see that some changes in the production are becoming more it is becoming stronger, the bioproduction year by year, or do you still see some skepticism for bioproduction and still a relevance on conventional ways? I mean, you said it's not automatically, sometimes conventional might be even better, but in general, like from a broader point of view, not just the lycopene case, do you see a trend moving towards this bioproduction now? Can you comment on this? I'm curious.
I think, Yanni, you are the expert there.
Well, you can definitely see that there's more and more novel processes being developed at the moment, some of which definitely scale, although scale up is usually a big hurdle. It's not that easy, so it is important to evaluate from early on in the development of a new cell line that should produce something later on, that you evaluate how this will affect sustainability and will it ever be also economically profitable, and then of course to allocate the right amount of money to the most promising developments. And there are a lot. So there's a lot of groups working on different cell types, cell lines, and novel products. And there's more and more coming also to industry, to industrial level. But what I think BIOS is also trying to reach here is to make this process more efficient, reliable, and faster in the end by developing this biointelligent design, build, test, learn cycle. And I think this is something which can make a difference in the future. A more data-driven, autonomous maybe in the future development of cell lines for future production use case.
Nice, because I was going to ask you how the biointelligence should support future biomanufacturing decisions. So I guess you already partially answered this way. So I don't know if there's something you would like to add.
Maybe to put this more to this perspective of this project, the part biointelligence by its definition is very broad. Convergence of biology, hardware, and technology, or information technology, I mean. But what does that mean in each and every different use case? In this one, I definitely see the approach, how do we get more data from the biological process. Not only later on in the production, that's for sure also another use case, but also already in the development. How can we speed up the development cycle by early on not only acquiring this data, but also analyzing the data and comparing it to data other groups have been doing on at the world. So you have more interchangeability, interoperability. Then the whole process of designing, building, testing, and learning from the data to automate this, setting on top a AI system in the future, which is giving you recommendations on which could be the more promising way, and basically building up you could name it a digital twin, or at least a digital infrastructure, which helps the development and the cooperation between all the partners. And then if you take a look at what others are doing at the moment, you see different companies going in the direction of autonomous laboratories. You see that they're at least this year and end of last year moving from generative AI to agent-based systems, where you can not only have your essay being drafted and your design of experiment generated by AI, but in the future also going more into the direction where this DOI is then passed on a scheduling agent, which is then transferring all the tasks on the equipment in a automated facility. And you have different agents then talking on this platform on your facility, and optimizing the process while the process is running. Not just steering through, not just reading out what you planned from the beginning, but actually modifying the process as it is running and trying to get the best data from it in a highly efficient way. And that is really something which I think will take a few years, maybe years, but you see a lot of different use cases being proposed at different events at the moment. And I'm quite confident there's going to be major change in this field.
Well, that connects also to the former discussion we had, so about the transition towards more bioprocessing instead of conventional routes. So I guess including this biointelligent approach, for example, new advancement in agentic AI, for example, as you mentioned, this vision of automatic and automatized infrastructure where we can have AI in place that can support and helping the automatization. That's really something that could also help the transition, also economically valuable. So because if everything is optimized, at some point we could also see the economical benefit on this. So this was to kind of connect our previous discussion. Biointelligent. Speaking about biointelligence, we are going to have an interesting meeting in September 24 and 25th in Toulouse, where BIOS Consortium is going to meet with the IBISBA, the IBISBA infrastructure, and also BIOINDUSTRY4.0, which is another European consortium, where there will be a lot of exchange about new technology advancement and biointelligence. But I know that especially Fraunhofer is very active in another biointelligence event that has happened for quite some years already, I participated to one. It was it was really fascinating. There were a lot of super interesting topics that have been treated there. And I'm talking about the Biointelligent conference. I don't know if you, Yannick, want to mention something about that as well.
Yes, sure. So you're talking about the Biointelligence Congress. This is going to be the third Biointelligence Congress. It's happening on the 6th of October at a trade fair in Stuttgart, Germany. And it is internationally an international event. And they're going to be around 300 to 400 people from academia, industry, politics, all gathering from different disciplines. So I suppose most of them will come from the biotech background. Few will come definitely from the engineering, production side, and from the AI, data-driven digital twin side. And we have a nice one-day program. There's also a delegation trip planned around. So the day before and the day after, there's going to be visits of companies and research institutions. So that could be something interesting. We have an exhibition area where companies and research institutions can demonstrate some of their prototypes, products, etc. There's still a few speaker slots left. If anybody is interested, it's going to be the Biointelligence Award, sponsored by Wittgenstein, 20,000 euros for the best company and 10,000 for the best researcher. So I think we have a quite nice framework program around it, focusing in the afternoon on 3 main tracks: on the food track, on the biomanufacturing track, and then on the health track. So I guess it's a very nice meetup for people in this area that want to drive forward topics at biotech, AI, and novel and scaling production technologies.
Amazing. So I would wrap it up saying, if you are really interested in the topic, that the Congress you want to be, right? So you presented it very in a very interesting way, so captivating way. So I'll definitely join. And yeah, Anna, Yannick, thank you very much. This was very useful. This was a very interesting look at how Fraunhofer work in BIOS connect sustainability assessment, life cycle engineering, and well, the broader idea of biointelligence through very concrete examples you made. So again, thank you for joining me today, and everyone for listening. So yeah, thank you very much, both of you.
Have a nice day.
Thank you for having us.
So, okay, see you.
See you. Bye-bye.
Bye, see you.